Hello and welcome. In my series about infrared ground observatories, today we'll look at Gornergrat Observatory, or the TIRGO. As always, first something about history and motivation of the observatory, then equipment, geography, some of the results, and an outlook. On the Gornergrat, first people built a hotel. This was back at 1896. By the way, Gornergrat is a crest in the mountains high up. And 2 years later, a railway was opened, the first electric cogwheel railway in Switzerland, they say. And then a lot later, 2 astronomical observatories were installed in the towers of the hotel. Actually, we could see this on the opening picture. There's a smaller one here that we will talk about, and a larger one here that we will shortly mention. One used to be a solar observatory used by the Oxford University, and then the Consiglio Nazionale delle Ricerche Italiano and the Arcetri Observatory in Firenze used the cupola to install the 1.5 meter TIRGO Cassegrain telescope. This used to be the largest optical telescope in Switzerland. And the other cupola was rented by the CNRS and the Observatoire de Genève, and had a 1 meter telescope and later a 3 meter sub-millimeter telescope from the University of Cologne. This was called COSMA, and later it was transferred to Tibet, because sub-millimeter as well as infrared telescopes, they need a sky as dry as possible. So Tibet probably was better than Gornergrat. And in 2010, professional observations ended in the Gornergrat. Then later there was a pedagogic project. I will show you a picture of that in the end. And this is accompanied by the universities of Bern and Geneva. One important aim of the observatory was to observe interstellar medium. And here there's an example picture with the visible light and the infrared in the K band, so around 2.2 microns. The equipment, as told, there was a 1.5 meter Cassegrain telescope, and it could be rotated almost on the whole sky. And the focal length was 30 meters, which is an f of 20, quite a long f. And there were various instruments on this telescope, and you can almost already tell that it was also to collect experience on the materials. So the university could just build better and better cameras and spectrometers, and they could be tested with this relatively large 1.5 meter telescope. By the way, probably everybody knows the mountain here in the background, the Matterhorn, which is the most prominent, not the highest, but the most prominent mountain in Switzerland. Table 1 here gives a list of all the, not all, but they say the list is probably incomplete, most of the instruments that measured on this 1.5 meter telescope. And for example, the Arnica camera that is mentioned in many papers and measured in the near infrared or shortwave infrared, depending on your definition, was cooled to 76 Kelvin. And the mechanics of the telescope were built in Italy and the optics in France. Then the geography, which is very interesting and very nice, as you have seen. It's on 3,135 meters, which is quite typical for an infrared telescope, actually. But it's quite easy to reach because there's a railway ending right where this hotel and the observatory is. And there's a little platform on top of the crest here for viewing. That's probably where these pictures were taken from the observatory. And the observatory is on 45, almost 46 degrees north, which is right in the west wind zone. But here on the larger picture you can see lots of glaciers. Here is the observatory. And by the way, here is the Matterhorn. Here is, on the south is Italy and the rest is Switzerland. And here is Zermatt. So this is where the railway goes up here. And there's a little bit of a trough here, which is a good idea because in the west, 10 kilometers west, you have a barrier that keeps away the winds, and then the air will fall and will dry up if there's west wind. It's still not the perfect place to observe stars in Switzerland, which would be probably the Upper Engadine. The art is, if you're in the Alps, to have a large valley. And the valley within the Alps has to be large enough to dry up the air if it comes from either side, so north or south. But the valleys is a valley that goes more or less west-east. And it is probably not perfect. It would be better to be in the wind shadow of some really high mountains and maybe a little bit further down. But we'll come to that later. Here they actually give graphs on how many nice nights you have to expect. And the left one was made by the other observatory, so the one in this cupola here. And actually I'm not sure if that is realistic and how many years they used as a databasis before sending it to the Italian guys making the infrared telescope. Here they compare TIRGO with Mauna Kea and the Paranal mountain in Chile. Here they say Paranal is just nice, the same nice for the whole year, whereas Mauna Kea is nicest around April, May, and on the Gornergrat it should be nicest in December and January. Once I did this is in Switzerland, and once I did the statistics at my home place and found that across the year there were 84 evenings that you could use for observing astronomy. A bit more mornings than evenings probably, but some, yeah, a fourth to a fifth. Of course, this valley is maybe better, especially in winter, than the place where I lived. Then they gave they listed some results and also gave some statistics on how many papers were published, refereed papers and papers in total. The papers that are not refereed are mainly in Italian and are reports for the money givers, things like that. Papers were, for example, on stars, on special stars like interacting binaries, on active galactic nuclei, which we have seen earlier in other infrared observatories. There were also multispectral observations and follow-ups of observations of the ERS satellite, but also on high-energy observations like UV or X-ray. And interestingly, they often used lunar occultations, we will see an example later, to observe stars or binaries. They also made some comet observations, and they also wrote technical papers of newly developed devices. We will not discuss these in what's coming. One notable result that we seen in an earlier video was the impact of comet Shoemaker-Levy 9 into Jupiter, which can be seen here, and the picture actually was taken on the Gornergrat with the 1.5 meter telescope. And they even plotted the fragments over time impacting into Jupiter. The data from the telescope is fully available for external researchers, together also with the data from the TNG. I will probably talk about the TNG in a later video. The Telescopio Nazionale Galileo. The Italians are proud because they had one of the first persons looking at the stars with a telescope, which was Galileo. And he also did physics a lot, was very important person, as most of you may know. For example, also in mathematics and physics. I didn't try to get into the archives, but it's still open for collaborators. And these were the people that more or less were responsible for the data. This is actually an image in the visible range of the planetary nebula NGC 2346, but here is a picture taken on the infrared telescope, the 1.5 meters, in the near infrared. And I gave you the details of the paper too, where you can read. They took spectra of the nebula to characterize it better. One thing they also did is estimate Aldebaran's angular diameter, and they based on two kinds of data. One was interferometry, which I also discussed in an earlier video, and the other is they used a lunar occultation to measure the diameter. So you just measure first and last contact, and then you know how far the moon moves. Actually, there's an angle because it doesn't hit centrally, but this is something you can calculate, and then you can estimate the diameter of Aldebaran. Here you can see it's in the high 8s, and the Pleiades are also very close. This is actually an even more impressive picture taken, but this is easier to see on that one. So all the estimates were around 20 microangular seconds. So this is the very border where the best telescopes that are being built right now will be able to resolute the star maybe 4 pixels and not as 1 pixel as it is now in the telescopes that we have now. So now I come to the summary. Why was the telescope discontinued? I don't know actually. It was close to the hotel, which may have implied compromises with the light, and there may be better places worldwide with more useful nights a year, although the statistics they showed was very nice, but this was done before they started observing, and I'm not sure if this was correct. And the work was moved to more specialized observatories and also larger telescope like the TNG and a very large telescope from ESO in La Silla. And by the way, a similar fate happened also to the other professional observatory in Switzerland, which was the Jungfrau Joch Observatory, which I don't think is in use anymore, with the 76 centimeter telescopes that it had there. But there is still a small, not so small amateur observatory on the Gornergrat, which has this nice, I think 60 centimeters telescope built by Officina Stellare, and you can also see there are 2 Takahashis here to take pictures. So quite a well equipped amateur observatory up there, but not a professional anymore. And this is a last view on the observatory as seen from below of the hotel. Very nice place up there. Thanks a lot for the attention.